I'm going to review concepts from Module 5 in preparation for your test. So in Section 1, we talked about solving systems of equations by graphing. So there are two scenarios you might be presented with. The first is that you're given a graph of a system of equations and you want to find their solution. So remember, we look for where the two lines intersect. And then we write our answer as a point. So these two lines intersect at the point 3, 5. You also want to make sure that you are paying attention to the scale of the x and y axis to make sure you are identifying the coordinates correctly. Okay. So for question 2, we're given a system of equations and we want to solve it by graphing. So we are going to use Desmos. So we can just graph the two lines in Desmos and find their intersection point. And when I graph the 2 points in Desmos, we get that the two lines in Desmos, we get that they intersect at the point 0, 10. Okay. In Section 2, we talked about solving systems of equations using substitution and elimination. So you are required to do both of them on the test. On some problems you'll be able to choose, and on others you will be told which method to use. So in question 3, we want to solve, we're actually going to use substitution here. So because looking at my system of equations, we have y isolated already in one of them. We have 4x minus y equals 3 and y equals 4x minus 9. So if one of my variables is already isolated, I know I'm going to use substitution. So we're going to replace y in the first equation with 4x minus 9. And I am putting it in parentheses because of that minus in front of y. That minus needs to apply to everything, not just the first term. So in distributing the negative, we get 4x minus 4x plus 9 equals 3. 4x minus 4x is 0, and we're left with 9 equals 3, which is not a true statement, which means we have no solution. So remember back to the notes, if both variables cancel and you are left with a false statement, it is no solution. Our second equation, we have negative 5x minus 3y equals 3 and 10x plus y equals negative 1. And I'm going to use elimination here. Could use substitution, but I'm going to give you guys an example of elimination. So I have to decide which variable I want to eliminate. And if I look at my system, both my variables already have opposite signs, so I don't have to worry about multiplying by a negative. So then it just becomes, do I want to eliminate x or y? Because I can easily make the negative 5x a negative 10x, and I can make the negative 3y, the y in the second equation, a 3y. I'm going to go ahead and multiply the first equation by 2, just because it involves having smaller numbers than if I multiplied the second equation by 3. So we get negative 10x minus 6y equals 6. The second equation stays 10x plus y equals negative 1. We're going to add the two equations together. The x's are going to cancel. Negative 6y plus y gives us negative 5y. 6 plus negative 1 is 5. Dividing by negative 5, we get y equals negative 1. Now I want to plug that into one of the original equations to solve for x. I'm going to go ahead and plug it into the second equation just because it involves less negatives. So it becomes 10x plus negative 1 equals negative 1, which I can rewrite as 10x minus 1 equals negative 1. Adding 1 to both sides, we get 10x equals 0. We'll divide by 10, and we get x equals 0. to remember this is not no solution because I still have a variable. No solution only occurs if the variable cancels, not the constant. If I wanted to write my final answer as a point, I would write it as 0, -1. In section 3, we looked at applications of systems of equations, so word problems. Our first example says a particular algebra text has a total of 1,382 pages, which is broken into 2 parts. The second part of the book has 64 more pages than the first part. How many pages are in each part of the book? So first, I'm going to identify my variable. So I'm going to let x be the pages in part 1 and y be the pages in part 2, because we know that the textbook is broken into 2 parts. Okay. That's going to lead me to my first equation. So the 2 parts total the 1,382 pages, and we know that the second part has 64 more pages than the first part. So I know the second part, y equals 64 more than, which is plus, the first part, x. So look at this system of equations. It's set up to use substitution to solve for x and y. So I'm going to take y and plug it into the first equation. So we get x plus 64 plus x equals 1382. Combining like terms, we get 2x plus 64 equals 1382. Subtract 64 from both sides, we get 2x equals 1318. Then we're going to divide by 2, and we get that part 1 has 659 pages. Okay, now to solve for y, we know that it has 64 more pages than part 1, so I'm going to use 64 plus 659. And we're going to get that part 2 has 723 pages. And I can double check that 659 plus 723 is 1382. One of the other things is we got to make sure that when we're solving a system of equations word problem, we remember units when we finish solving. So in this case, those units were pages. It could be money. It could be a speed, like miles per hour, kilometers per hour. So you got to make sure you include units on your final answer. On number 6, we have that on Monday, Joe bought 10 cups of coffee and 5 donuts for his office at the cost of $16.50. Turns out that the donuts were more popular than the coffee, so on Tuesday he bought 5 cups of coffee and 10 donuts for a total of $14.25. How much was each cup of coffee? So I'm going to let x be the cost of coffee and y be the cost of donuts. So we know 10 cups of coffee and 5 donuts cost $16.50, and then 5 cups of coffee and 10 donuts cost $14.25. So I'm only asked to solve for one variable here, the cost of a cup of coffee. So I want to solve for x. So I'm going to use elimination to get rid of y. So in order to get rid of y, I'm going to multiply the first equation by -2. And I will have to multiply by a negative to get them have opposite signs. So the first equation now becomes -20x minus 10y equals -33. And our second equation stays 5x plus 10y equals 1425. We're going to add the equations together. This time the y's will cancel. negative 20x plus 5x is negative 15x, and negative 33 plus 1425 is negative 1875. Dividing both sides by negative 15, we get that a cup of coffee costs $1.25. And if I needed to, I could solve for the cost of a donut. Okay. So we're actually going to combine sections 4 and 5 because section 4 was just kind of a reintroduction of linear inequalities. So in section 5, we talked about systems of linear inequalities. So when we're looking at a system of linear inequalities, and we want to graph the solution, we are going to plot each inequality, and then we only need to shade the region where they overlap. So I'm going to graph both of these inequalities, y less than 3x plus 1 and 5x plus 2y less than or equal to negative 4 in Desmos. So using Desmos to help with the graphs. So the red line is the y less than 3x plus 1. And then we'll do the blue line for our second one. Okay, so there's a rough drawing of our inequalities. So now I want to shade the region where they overlap. So that would be the darkest region on Desmos, which is this bottom part. So we're less than the red line, and we are less than or equal to our blue line, which is where the green region is. Okay. Now we want to check to see which points are solutions to our system of inequalities. So what you can do is you can actually graph these points in Desmos and figure out if they fall in the shaded region. Now, any point that falls on a line, it depends on which line it's on. So in this case, points that fall on the blue line can be solutions to the system if that point is also in the part that is the shaded region. So that first point, 0, negative 2, is the y-intercept of our blue line. And it does fall in the part of the shaded region where they overlap, so it is going to be a solution to the system. On the reverse, if we look at the y-intercept of our first line, 0, 1, so it's on the line, which means it's automatically not a solution because that's a strictly less than. And it's also not in the shaded region, so no. Okay. Next we have negative 5, 1. Now it's only in the solution region for our blue line, not both, so no. And then we have negative 2, negative 10. And that falls squarely in the region of both inequalities. So it is a yes. So the last section, section 6, talked about linear programming. So what we want to do is graph all of the inequalities in Desmos and then first identify the vertices of the feasible region, which is the solution region. So we have x greater than or equal to 100, x less than or equal to 200, y less than or equal to 170, and y greater than or equal to negative x plus 200. And you will have to zoom out here to see all of the inequalities. Right. And then again, we're looking for the darkest region. And there are going to be 4 points that contain our solution region. And those are the points 100, 170, 100, 100, 200, 170, and lastly 200, 0. Those are the 4 points that contain the darkest region of all 4 inequalities. Next, in the last problem, we want to find the coordinates of the vertices of the feasible region, then find the maximum and minimum values using the function. So we're going to start with x plus y greater than or equal to 7. X plus 2y less than or equal to 12, and then x greater than or equal to 0 and y greater than or equal to 0. So we have, if we look for our darkest region, we have a triangle that is going to contain the darkest region. So our points are going to be the points 2, 5, 7, 0, and 12, 0. Now we want to use that equation 500x plus 300y to figure out which one is a max and which one is a min. So we're going to do 500 times 2 plus 300 times 5. And we're going to get 2,500. Next, we're going to do 500 times 7 plus 300 times 0, and we're going to get 3,500. And then lastly, 500 times 12 plus 300 times 0, and we're going to get 6,000. So our maximum comes from the point 12, 0, and our min is going to come from the point 2, 5. Let me know if you have any questions over anything from Module 5 before taking the test.